All right, so good afternoon, everybody, and welcome to day two, the end of day two of our epic deep dive into climate change. All week long, we are featuring scientists and explorers from around the globe, truly around the globe, this festival, to highlight the science of climate change, what people are doing about it to help mitigate it, and more understanding of it around the globe, from Arctic ice cores to islands being inundated in the Pacific Ocean. We've covered the gamut. This is our 11th program of 23 this week, and if you haven't checked it out, all those programs are on our YouTube channel at an ever-growing playlist. Today's presentation is my favorite personally of the entire week. It's always exciting to have our speaker on with us. So we are joined live by Nick Underwood, and he is part of the National Oceanic and Atmospheric Administration, or NOAA's Hurricane Hunters. While the rest of us are fleeing away from hurricanes, Nick is flying into them to help understand how they develop, understand where they're going, get those charts so we understand where they're going to track up coast or into the Gulf of Mexico. He's the one who helps us understand that and get a better prediction to make sure that people's lives are saved and property is saved as well. So Nick's an all-star. I'm so excited to have him back. You guys are in for a real treat. Without further ado, I'm going to turn it over to him to blow your minds. Nick, thank you so much for joining us today, man.
All right. Yeah. Thanks for having me. Always happy to be here. Hello, everyone. As you said, my name is Nick Underwood. I'm an aerospace engineer with the National Oceanic and Atmospheric Administration's Aircraft Operations Center, which you probably know better as the NOAA Hurricane Hunters. And today we're going to talk a little bit about hurricane hunting, a little bit about some of the missions that we support up in the Arctic, and what ties those together. So I'm going to share my screen because I've got a nice presentation for you with a lot of cool imagery, and we will get going. All right. So this is a satellite image of Hurricane Florence in 2018. And this was taken when that storm was a Category 4 hurricane roaring its way across the Atlantic. I was part of a crew that would do 3 missions into this storm, all the way from when it was a tropical storm up to a Category 4 hurricane. And ultimately, this would make landfall in North Carolina, cause about $24 billion in damage, and kill about 50 people. And so why do we fly hurricane missions? So on the left are all of the flight tracks from our P3 aircraft, which we'll talk more about in a minute. All of the flights and missions that we flew into Hurricane Dorian in 2019. So we started out when the storm was still down near Barbados and the Antilles, flew it all the way up to where it was sitting over the Bahamas, and then kept chasing it all the way up until it made landfall in the Carolinas. And what we're doing on these missions is collecting important atmospheric and oceanographic data that fuels prediction models that allow us to predict where that storm is going to go and how strong it's going to be when it gets there. So on the right is a product produced by the National Hurricane Center. You've probably seen it before, called the Cone of Uncertainty. And so this is the best estimation, the best prediction of where a storm is going to go over the next 5 days and what kind of intensity it's going to be at different points during its life cycle. So the shaded area is the best prediction 3 days out, and then the dotted area is 5 days out. And so the more data that we can collect, the more accurate those prediction models can be, and the earlier that we can warn people on the ground that a storm is headed their way. So we have 3 aircraft that we use to hunt hurricanes. They are named after Muppets, Kermit, Miss Piggy, and Gonzo. And we're going to talk about Gonzo first. So this is our high-altitude hurricane surveillance jet. So we call him Gonzo because he's got a big funky nose here. But essentially, this is a modified business jet that we use for science. So Gonzo flies up above, around, and in front of the storms, up at 45,000 feet, so way up in the sky, to gather that upper atmospheric data that really determines the steering currents and where those storms are going to go. We have 2 primary instruments that we use aboard Gonzo to collect that data. The first is called our tail Doppler radar, which is in this bulb-looking apparatus sticking off the back of the tail. So, So think of that like an MRI of the storm. So as we're flying around, that radar is getting us a picture of the storm from the sea surface up to the tops of the clouds. And this is the kind of returns we get back from that instrument. So this was flying around Hurricane Eta, and you can see we've got the sea surface below us, and then off to the right here, those are all of the storm clouds of Hurricane Eta. And so as we fly around, we take those slices and get a good picture of what that storm is, what's happening inside of that storm and how it's developing. And the other instruments we use are dropsondes. And this is really my job on all of these aircraft, is to launch these instruments and operate the data systems that they feed to. So think of these like weather balloons in reverse. So we have tubes on the bottom of the aircraft that we can launch these out of. And they're just little atmospheric sensing packets. So they've got a parachute, and as they're falling down through the atmosphere, they're collecting pressure, temperature, humidity, wind speed, and wind direction data for us. All of that stuff that is going to get us a good idea of how that storm is developing. And the data from these is so critical and really allows those prediction models to be a lot more accurate. And a good example of this is Hurricane Katrina in 2005. So in this plot on the right, the red line is the best prediction of Hurricane Katrina without using the data from the dropsondes. And you can see that it took it way over into the western part of Louisiana. The green line is the best prediction model with the data from the dropsondes. So that takes it up towards New Orleans and then to Mississippi. And then the black line is the actual track of the storm. So you can see just how well that prediction model using the data from the dropsondes lines up with what the actual track of the storm was. And so, as I said before, the more accurate these models can be, the more accurate those predictions, the more people that we can keep safe on the ground. And that's the whole goal of these missions. So the other aircraft that we use to hunt hurricanes are our Lockheed WP-3D Orions. This is Miss Piggy in the photo. Kermit is the other aircraft that we have. And these are flying research laboratories. So these are pretty big aircraft. We usually have about 12 to 15 people on board as we fly through the hurricanes. And they're teaming with all sorts of different atmospheric science instruments. So we've got 3 radars on board, one in the nose, one in this sort of M&M looking structure on the bottom. And then we have a tail Doppler radar, just like on Gonzo. There's a pod on the wing that gets us cloud dynamics, so water droplet, size, speed, and direction. And there are tubes all along the bottom that we can launch dropsondes and other ocean sensing instruments out of. And so Gonzo's flying up at altitude, 45,000 feet, around the storm in front of it. Our P3s, Kermit and Miss Piggy, they're flying closer to the ocean, usually between 8 to 10,000 feet, and they're flying right through the hurricane. So we will set up on an inbound track, just target the eye of the storm and head straight for it. And so Gonzo's gathering all of that data that really helps us predict the track of the storm, where it's going to go. And then our P3s really give us a good idea of the intensity of that storm and how it's developing on the inside. So what's it like to fly through a hurricane? Well, it's kind of like being on a wooden roller coaster through a car wash. So it's very bumpy. There's a lot of vibration, and there's a lot of wind and rain and whatever else getting slapped against the windows. And this is the view for most of the flight. But eventually, especially with more powerful storms, you break out into the eye. And the eye really is a super calm area of the storm. It's just like being on a commercial flight. So this was flying through Hurricane Florence. And you can see we've just broken into the eye. We're leaving those nasty storm clouds behind us. And you can see that it's clear. There's blue sky up here on the left. I'll skip ahead a little bit here. Maybe I'll skip ahead. There we go. So you can see there's blue sky above. And we call this the stadium effect. And this happens with more powerful storms, usually category 3 and above. So we're down at 8 to 10,000 feet, but these cloud tops, depending on what latitude you're at, can reach up to 30, 40, or 50,000 feet. And so you're sort of at the bottom of this bowl, and it looks like you're standing on the field of a football stadium, looking up at all the stands around you. And we do a lot of turns in the eye. This is where the actual hunting of the storm comes in. So we're trying to find the center of pressure, that point where all of that energy in the hurricane is trying to flow to. And the more accurate we mark that point, the better that those prediction models are going to run. So we will skip ahead here. And so I've seen some interesting eyes over the last few years. This was Hurricane Dorian. This was when it was a category 3 storm. So this was after it was a category 5 and had lost a little bit of its strength on its way up to the Carolinas. This was Hurricane Florence in 2018. This is my favorite photo of a hurricane eye. It was just a beautiful storm on the inside, and you can see the curvature of those clouds at the top. And these missions that we fly on the P3 and even on Gonzo, they're long missions. They're usually about 8 hours in length. So this is a time lapse of a single pass through Hurricane Florence. So you can see we're going through the rain bands, into the eye wall, which is the most violent part, out into that beautiful eye, and then right back out the other side. And just to really exemplify the difference in flight tracks that our aircraft fly, this is Hurricane Matthew, which was actually the first hurricane I flew into. And on the left, you have a flight track from Gonzo. So you can see they flew out into the Atlantic up here, around the storm, even out into the Gulf of Mexico, really just sampling the environment around the storm, getting an understanding of what's going to flow into it and what might impact it. And then compare that with a P3 flight track, which is just zigzagging and crisscrossing all throughout the storm, sampling as much of that storm as we can. And what I really want to talk about today, to shift more to climate stuff with hurricanes, is a process called rapid intensification. And this is where a storm gains a lot of strength over a very short period of time. It's considered 35 miles per hour of wind speed over a 24-hour period. And Hurricane Florence was an excellent example of this process. So I took this photo on September 8th of 2018. This is a picture of Tropical Storm Florence. So you can see there's some low-level circulation. There's some light on the horizon over there, so it's not a super crazy storm yet. This was 24 hours later on September 9th. So this is Category 2 Hurricane Florence. So you can see the sea state has really kicked up. There's some big swells down there. It looks a lot more violent up through here with thunderclouds and all of that. And then 24 hours later, we had this, which was Category 4 Hurricane Florence. Now, thankfully, this storm went through this process way out in the Atlantic, didn't bother anybody. But we've seen, especially in recent years, hurricanes Dorian and Michael, for example, storms going through this process closer to land, which can be very dangerous for people on the ground. And another great example of this process was just last year with Hurricane Laura. And so we flew missions all throughout Laura's life cycle when it was Tropical Depression 13 up until it made landfall in Louisiana. And so this was the National Hurricane Center's prediction 3 days prior to landfall. So you can see the storm is still down over Cuba, but it's projected to make landfall in western Louisiana as a hurricane on Wednesday night. 24 hours later, the storm had moved off of Cuba, still projected to hit up in the western part of Louisiana. This is 2 days before landfall, and it's projected as a Category 2 hurricane or below. And it was this morning that we found Laura as a hurricane. It had intensified from a tropical storm up to hurricane status. 24 hours later, Laura was churning over the Gulf, and instead of a Category 2 hurricane or below, we were now predicting a Category 3 hurricane or above hitting Louisiana. And the reason that that outlook changed was because Laura started to go through a period of rapid intensification where it was gaining a lot of strength very, very quickly. And so this is, a day before landfall, and the outlook has changed, and suddenly it's projected to be a lot more violent of a hurricane. And it's very difficult to predict when those storms are going to go through this process. And just to show, this was a picture I took the morning we found Laura as a hurricane. So you can see there's that low-level circulation down there. And then 24 hours later, it was a Category 3 hurricane churning its way over the Gulf of Mexico and heading straight towards Louisiana. So why did it go through this process? Well, there's a couple things that factor into hurricanes intensifying. Dry air can impact it, upper level wind shear that's trying to push that storm in a way that is going to mess up its rotation. But another thing that factors in is ocean sea surface temperatures. So hurricanes, as they go along over the ocean, are soaking up energy from the sea surface. So the warmer that water is, the more energy is available for that storm to come and soak up. And so if you look at the sea surface temperature anomaly, so this is the difference from the normal that you see at that time of year, this is the day that Laura started to rapidly intensify. And you can see that over the western Gulf of Mexico, the sea surface temperatures were a degree to 2 warmer than they normally are, which doesn't sound like a lot if it's 75 degrees outside versus 77 degrees outside. You really can't feel that. But when you spread that out over a huge area, that's a lot of extra energy to be soaked up. And we're seeing rising sea surface temperatures throughout the North Atlantic, especially in the areas where hurricanes form. And we're seeing rising sea surface temperatures in a lot of different places. And this is where we'll shift gears a bit and talk about the Arctic. And so our office also flies some missions up in the Arctic, whether they're marine mammal surveys or Arctic sea ice surveys or whatever. And what we're finding is that the ocean sea surface temperature is warmer than it has been. And so these are exciting missions. We fly only about 500 feet above the water. So you're cruising, pretty low above the Arctic Ocean. And you can look down and see seals and beluga whales and walruses. And I've yet to see a polar bear, but I'm really trying to. We use a smaller aircraft for these missions. This is one of our 4 twin otters. So they're just small twin engine propeller planes. But we load them up with just as much science instruments as we do the other aircraft. And just to say again, we're flying 500 feet, and the whole purpose of these missions is that we're collecting data on the atmosphere, seeing what the weather's like up there, and we're also launching instruments into the ocean to get temperature profiles and salinity profiles, which is how much salt content is there. And primarily we fly these missions above the Chukchi Sea, which is an area of the Arctic Ocean that's between Alaska and Russia. And we're really interested in this area because it's been losing sea ice and the water's been getting warmer at a lot faster rate than other parts of the Arctic Ocean. And so this is just an example of some of the instruments that we launch into the ocean. These are called AXBTs. They're airborne expendable bathythermographs, which is just a fancy way of saying they're ocean thermometers. And so we fly along, we drop these instruments out, they sink down through the water column, they give us that temperature data, and scientists can use that to understand what's going on here and why is the water temperature rising. And so we're interested in the sea surface temperature because the Arctic has been losing a lot of sea ice, especially over the last 40 years. And so we're going to go through some plots here just to really show you just how much is being lost, specifically over the summer time frame, which is where you would expect the most sea ice loss to occur. And we fly our missions in late May, early June, and then some other ones in the latter part of September. So after it's had, the whole summer to warm up. So you expect some sea ice loss because it's warm in the Northern Hemisphere during the summertime. So this is the sea ice extent in June of 1980. And you can see, okay, so the area we're really interested in is over here on the left side between Alaska and Russia. That's the Chukchi Sea. And so you can see at the end of the summer in 1980, the Chukchi Sea had lost most of its sea ice and had started to penetrate into this sea ice up here that typically stays there year round. And what we've seen in recent years is that the Chukchi Sea is losing its sea ice a lot faster, and that's allowing the rest of that Arctic sea ice to be eroded away a lot faster as well. So this is 2018, and this is the same time frame, June to October. So on the left, you've got June of 2018, and you can see that in June, most of that Chukchi Sea sea ice was already gone. And we can look back in 1980 just to see the differences there. And so June of 2018 kind of looks a lot like October of 1980. And so after a whole summer of melt, you see how much more sea ice was lost up in the Arctic. This is 2018. In 2019, a lot of the same story. The Chukchi Sea mostly melted away by June, and then by the end of the summer, a lot of the sea ice that normally stayed there year round had melted away. And then 2020, this last year, again, the Chukchi Sea, most of that sea ice already gone by June, and then a lot of sea ice lost up in the deeper parts of the Arctic. And so what used to be covered in sea ice is now just open water. And why are we concerned about this? So one is that it shows that this ecosystem is changing. Animals like seals and walruses and polar bears that depend on that sea ice, there's a lot less of it for them to live their lives off of. But what also matters is that sea ice is very reflective. And so when that solar energy hits sea ice, just because it's the color white, it reflects a lot of that energy back up into space. Whereas this dark ocean water absorbs more of that solar energy, which is going to raise the sea surface temperature more. And as the sea surface temperature raises, more sea ice gets melted away, which opens up more of that dark ocean water to absorb more energy, to raise the sea surface temperature more. And you can see how we get in a loop there of losing more sea ice, causing us to lose even more sea ice. And this matters because the Arctic, and I can play this video again to keep talking here. The Arctic sort of acts like an air conditioning system for the Northern Hemisphere. So lower latitudes, like the tropics and probably where you live, absorb a lot more solar energy than the Arctic does. But the Arctic traditionally reflects a lot more of energy from the sun. And so it acts as a sink. And so that warmer air, the warmer air and the warmer water from the tropics can flow up to the Arctic, and everything sort of balances out and keeps things at a nice temperature. And as we start to lose the sea ice, the Arctic becomes less, it loses that cooling aspect and is really going to allow the Northern Hemisphere to heat up even more. And over the last 40 years, we've seen a lot of sea ice loss. And so this is a chart from 1979 to just this last year showing, and this is September sea ice coverage. So you can see from 1979 to last year, we've lost about 3 million square kilometers of sea ice, which is about 4 times the size of Texas. And this is at the end of the summer. So that's a lot less area that's reflecting that solar energy. And instead it's getting absorbed into the oceans. And part of that sea ice loss is, that sea ice loss is connected to rising global temperatures. So if we look back all the way to 1880, we can see that we're on a pretty upward trend of the globe heating up, both in oceans and over land. And this is just the land, and this is the departures from normal just for last month, February 2021. You can see that most of the world is warmer than it used to be. The United States is pretty cold. There was that big snowstorm that made its way all the way down to Texas. So February was a little bit of an anomaly there. But if you look at the last few years, America has also been included in the areas that have been warming up. And why are things getting warmer? Well, we've done a lot of research and we've tied it to greenhouse gas emissions, specifically carbon dioxide. So as we burn coal and natural gas and oil, we're taking carbon that has been sequestered in the ground for millions of years, and we're pumping it into the atmosphere where it can trap more of that solar energy and raise temperatures. And so over the last 800,000 years, and we have data going this far back from looking at ice cores and sediment cores down around Antarctica, and we know that within the last 800,000 years, carbon dioxide levels haven't been this high on this planet. And they've been this high at points during Earth's history, but that was tens of millions of years ago when life on this planet was completely different. So you can see that, it tends to cycle, but we've really been pumping things up over the last couple of decades as we burn more and more fossil fuels. And this is just atmospheric carbon dioxide since 1975. And you can see there's a pretty positive upward trend there. So what I want to say with all of this is that hurricanes are impacted by rising ocean temperatures. The Arctic is impacted by rising ocean temperatures, and those are linked through climate change. And that's linked through our burning of coal, natural gas, and oil, fossil fuels that are pumping all of that carbon into the atmosphere, trapping more of that energy. We're just continually adding energy to that system and not removing it as efficiently as we used to. All of the data that we talked about today, you can find on climate.gov. For the hurricane products, you can go to hurricanes.gov. And then for those sea ice index plots, the National Snow and Ice Data Center has all of those plots going back all the way to 1980. You can look at monthly plots and daily plots and whatever else. And that is the end of my talk. I know that's a lot of information to take in, and I hope you can kind of see the connection between the Arctic and hurricanes, even though they may be in completely different parts of the world. They are being impacted by the same processes. And I'm happy to answer questions on anything.
Nick, that was amazing. You certainly did pack in like a 45-minute talk into 20 minutes. That was awesome. We're going to dive in with questions, guys. We've got our 6 live classes. We've got a whole bunch of you tuning in on YouTube. If you're on YouTube, let me know where you're joining from. We'd love to take questions from teachers. I'll give our live classes just a second to sort of gather their thoughts, and I'll share this question, which I'm sure every class has, which is from Jason on YouTube. Why do you trust an airplane to go through a hurricane? Are they just crazy strong, or like what's going on? Planes?
So our aircraft, we use P3s, which the United States Navy originally used to hunt submarines, but we just use them to hunt hurricanes. And so they're pretty sturdy aircraft. And we, through doing this for the last 50 years or so, have really just gained a lot of knowledge about how to do it safely. And so we have a lower limit on our altitude that we try to stay above. So we're not too close to the ocean in case something goes wrong. We fly through at very certain speeds to reduce the stresses on the aircraft. And we also are using those radars on board to really pick and choose how we get through that storm to dodge some of the more violent parts. And so there is some risk involved, but we absolutely do it as safely as possible.
Great question, guys. And I mean, we've been dealing with risk in a lot of our programs this week, going up to the Arctic, Antarctic, flights like this. There is an inherent risk involved, but a lot of preparation goes into this. The hurricane hunters don't go into this lightly. There's a lot of great technology that goes into it and planning by Nick and the rest of the team. So I'm really glad we got that question to kick off. Let's go to Gambrills, Maryland. Miss Raheem's class. We're going to kick off with you guys. If you have a question out there in the hallway, come on in.
Thank you. So Olivia has a question.
How many hurricanes have you chased in your lifetime?
How many hurricanes have I chased in my lifetime? I think the number is 15 or 16. We had a very, very active season this last year, and I sort of lost count at some point. So I need to go back through my notes and actually count up the number. But I think it's 15 or 16. So I've been part of this team for the last 5 years. And typically we get a couple of good hurricanes every year, at least the more powerful, pretty ones, which of course aren't the ones that you ever want to see because they go and wreck people's homes and livelihoods. But the whole purpose of doing this job is to protect those people on the ground from those storms.
Great question, guys. And I think we can all agree that it's pretty awesome to be in a situation where it's like, how many superstorms have I flown into? I don't know. I want to take us to Tuscaloosa, Alabama, Miss Foster's class, who look like they've done a drawing for you too. So this is like these are like some serious artists, Nick, and I'm excited to unmute your mic.
Oh boy!
Hey, Miss Foster's class.
Oh man!
Nice.
Very cool.
Hey, ladies, nice job. Unmute your mic. Share a question with us. Come on in. Go. Hey.
Hey. How did you become a hurricane hunter?
How did I become a hurricane hunter? So about 5 years ago, I didn't know this job existed. But so I'm an aerospace engineer by trade. And I was working with fighter jets up in Maryland, but I wanted to shift to something that was more science focused. And I just so happened to be looking for a job at the right time, and NOAA's Aircraft Operations Center needed a new aerospace engineer. And so my skills as an engineer of doing physics and thermodynamics and aerodynamics and all of that is I put to use to get new science instruments mounted to the aircraft and other things like that. And then the other half of the job is serving as aircrew aboard the aircraft. So actually flying through the storms and flying around the Arctic and just being a part of that team. So I always say I did kind of fall backwards into it. It was never something that I planned to get into, but it's a wonderful job and I'm very happy that I'm here now.
I think pretty much every one of our speakers over the last 2 days has had some sort of serendipitous thing happen that led them to the career they are in. And I think, when you're a student, you really think a lot of people, when I was a kid, I thought people, had a career plan, they set it, they ended up there, they did this one track to get there. And that seems to really not be the case. So I think that's really a nice message for kids. If you're keen on any number of things, keep seeking out opportunities and you never know what might happen. I'm going to go to Ms. Ball's class in Goderich, Ontario in just a minute, but we're getting a question we've never got for you before, and I love it. So Ms. Rader's class, is talking about the things you drop into the ocean. Is it bad for the environment? Does it add to ocean plastic? It's a big topic of our week.
So we do get that question a lot. So the dropsondes and the AXPTs and the other instruments that we're launching into the ocean, they are expendable. So we don't really have a way to get them back. It would be great if we could go, with a boat underneath the aircraft and pick them up as we launch them out. But I don't think anyone wants to be in a boat in a hurricane. But those instruments are designed to sink once they hit the water. So instead of just, sort of floating around in the water column, they do find their way to the seabed and get stuck in the mud. And we like to imagine they make nice houses for fishes. But I'm sure there is some kind of environmental impact by those instruments, but the data that we get from them is so important to people all along the coast and in, countries down in the Caribbean that right now we just don't really have a better way to get that data. So I think it's sort of a necessary evil.
It's been really interesting. I've really loved the classes this week. I've been asking about, ships going to the Arctic. Well, they burn fuel, so that contributes to climate change. It's like, yes, there's so much great work being done that it is something that you, as you said, sort of a necessary trade-off. But I love the spirit behind the question, guys. At least 4 classes asked that in YouTube chat bar, so that's awesome. Ms. Bowles' class coming to you guys next, and then Mr. Colin, Miss Fullen in a minute, and Miss Melika to wrap us up with a live groups. Miss Bowles' class, come on in.
You keep asking all my questions for me, Jesse, but I was curious. I'm assuming you're not flying every single day. So what does a day in the life of a hurricane hunter look like when you're not flying?
Yeah, so hurricane season is only 6 months out of the year, and we certainly don't fly every day, even during hurricane season. So as I said, I'm an aerospace engineer by trade. So when I'm not with the crew flying on the aircraft, I'm in the office and I'm doing engineering work. And a lot of that is scientists come to us with new instruments that they want to put on the aircraft, whether to fly through hurricanes or any of the other number of missions that we support. And it's my job to make sure that those get safely and securely attached to the aircraft. So they're not going to fall off. They're not going to go flying on their own. And outside of hurricane season, we also have a number of off-season projects that we support. And that's with the heavy aircraft, Kermit, Miss Piggy, and Gonzo. And so Gonzo was out in Hawaii chasing atmospheric rivers for the last couple of months. Kermit was up in Alaska doing a sea ice survey and chasing some North Pacific weather systems. And we've also got a bunch of smaller aircraft that are doing the marine mammal surveys. They're doing coastal mapping surveys, snow surveys, which are actually really cool because they help us predict when rivers are going to flood in the Midwest. So we support all these different projects. And so even though hurricane season is only a part of the year, we stay very busy the rest of it otherwise.
Great question. I think we've gotten that one every time we do a program with you, but it's really neat. Mr. Cull's class, we've got a bunch of groups in Ontario joining us today. So Mr. Cull's group is joining us in Cobalt, Ontario. If you guys have a question for us, come on in and go for it.
Hi, I had a question. I don't know if it's important or not. Like, why do you name hurricanes after real names? That's what.
So the World Meteorological Organization handles all of the hurricane names, and I think especially with larger storms that have the potential to cause a lot of damage, it's just a lot easier to give it a name so that. When meteorologists talk about it or when emergency managers talk about it, there's just, a simple, easy to say name that they can refer back to, and everyone knows, okay, that's the name of the storm and that's what we're calling it. And if you hear news about this, that is what we're talking about. So I think it comes down to a communication thing because these are very powerful and dangerous systems, and we want to better communicate that danger to the public, and the anything that will make it easier for that communication to happen is going to help everyone out in the long run. Yeah,
Hurricane N2649C4, doesn't really have that same sort of ring to it as opposed to
exactly
everyone knows and they're ready for it. And, yeah. Ms. Fullen's class joining us in Ottawa, grade 8. If you guys have a question for us, come on in, and then Miss M, we're coming to you guys in just a second. Go for it.
Yes, hi. So Connor is asking, is it scary realizing all the bad things that could happen while you're in the air? And what would you do if you're in the middle of an eye and an engine fails or a fire starts?
Okay, great question. So there are hazards like that that we have thought about and that we plan and train to handle. So fires on board the aircraft, for example, is something that can definitely happen. A fire in the middle of a hurricane is sort of the last thing you would expect, but it's actually one of the most dangerous things for us. So we consistently drill and practice and train to be sure that if that actually happens in a storm environment on a mission, that we know exactly what to do to handle that fire, to keep the aircraft safe and to keep ourselves safe. There have been instances in the past of the aircraft, having an engine stop in the middle of a hurricane. There's a harrowing story from 1989 in Hurricane Hugo about that. Luckily, they were able to get into the eye and circle inside of it up to a safer altitude and make their way back out. So all of that stuff can happen, but our crews, our pilots, our navigators, engineers, meteorologists, all of us train and make sure that we're ready for those situations if they actually happen.
It's a question I'm sure you get a lot in all your programs. The YouTube chat bar, by the way, went really dark with us, where the plane landed in the water and then jellyfish attacked you once you were there. So it went very off kilter. Miss M's class down the street from Miss Houlihan's in Ottawa. If you guys want to unmute your microphone, come on in, and then we'll take a few YouTube questions in a minute before doing another round. Hi, Miss M's class.
Hi.
Hi. I can't see myself. Come closer.
So we were wondering, what's the difference between a P2 and a P3 jet?
So P2 and a P3, I'm pretty sure the P2 was just an earlier iteration of the P3. I don't think they don't make P2s anymore, and they don't even make P3s anymore. Our aircraft are about 45 years old now. They came off the assembly line in the mid-1970s. And so they're very old aircraft, but they're still very reliable. And we have a great maintenance team that keeps everything working as it should. But yeah, the P2, I don't know too much about. The P3 I can talk about all day, though. We do have, so our two P3s are two of a kind. So they're WP3Ds. So they were specially made for NOAA back in the 1970s. And although they don't have that many differences from Navy P3s, they are very specialized, one of a kind, to carry all of our science instruments and everything else that we need.
And to follow up on this question perfectly, Miss Class on YouTube wanted to know, why don't you fly more modern aircraft? Like, why use something from the 1970s when there's, I guess, better technology available today?
Right. So NOAA has Hurricane Hunters, and the 53rd Squadron of the U.S. Air Force Reserve also hunts hurricanes, and they use C-130s. We still fly our P3s mainly because they still work and they do exactly what we need them to do, and they're great and reliable aircraft. There is a push over the next 10 years or so to get us new aircraft, and I think that process is starting sometime soon. We'll probably end up getting something similar to what the Air Force has, but what we really need is a 4-engine propeller plane to fly through these storms. And we use propeller planes instead of jets because with propellers you can react more quickly to updrafts and downdrafts throughout the storm, whereas a jet would potentially get choked out and takes a little more time to get that change in lift that you would need. But that's getting a little too much into the weeds of aerodynamics. But the short answer is that they're great aircraft and they work great for us, and that's why we still fly them.
Perfect. Thank you so much, Ms. Smith, for that question. Ms. Rahim, we are going to come to you guys live in a minute. I got your student waiting there. I just wanted to share this question from Ms. McRae and a few others on YouTube, which is, what kind of training do you need? Are there college courses? Is there a certain height and weight requirement like people think of for astronauts? Like, what's going on?
So for training, we have a bunch of different types of folks who work with us. So we have pilots, we have navigators, we have meteorologists, we have aerospace engineers, we have electrical engineers, we have electronics technicians, we have mechanics, and we have scientists, and there's so many different ways that you could get into this kind of job. I just happened to go the engineering route because I'm interested in space and rockets, and that's what I studied in school. There's really no height or weight limits. You do have to maintain a FAA physical, which basically, is not too difficult to get. And as far as training goes, I didn't know anything about chasing hurricanes when I started the job, and so a lot of it is on-the-job training of learning how to operate the data systems and learning the emergency procedures and everything else. And that's just something that I've learned at the job over the last few years. And I want to stress again that coming into it, I didn't know much about hurricane hunting at all.
Great answer. Thank you so much for that. Nick, by the way, I want to be respectful of your time. Do you have about 5-10 more minutes for another round of questions? Yeah. You have to run. Okay, perfect. Ms. Rahim's class then, let's go back to Maryland. If you guys have another one, come on in.
Yeah, we always do. Okay. Go ahead, Anderson.
I was wondering how if hurricanes make a big impact on climate change, and if they do, then what are the biggest ways they make on it?
Did you get that, or do I need to read
Yeah, no, I got that. So hurricanes themselves don't really impact climate change. It's really the other way around. So climate change is projected to have an impact on hurricanes over the next few decades. The data I always reference is from NOAA's Geophysical Fluid Dynamics Lab, where they predict that we'll see relative increases both in hurricane frequency, so the number of storms, as well as hurricane intensity. And a lot of that is driven by rising sea surface temperatures and just more energy being in that system available for storms to come along and soak up and become more powerful, or to even storms that maybe weren't going to reach a hurricane status suddenly have the energy available to reach that status. So yeah, the storms themselves don't impact climate change, but climate change will likely certainly have a impact on the storms.
Yeah. The favorite comment that I got on YouTube about that after that was that someone's dad has a book about fluid dynamics. So who knew? You're inspiring a generation here. Let's head back to Alabama, Miss Foster's group. If you've done a new painting in the meantime, by all means show it. But if you want to just share a question, you are all good to go. Hi guys, just demute that mic, and you're all set. Go.
We live in Alabama. How is the hurricane season looking for the year?
So for this year, I'm certainly not the person to ask about that. I'm not a forecaster or a meteorologist. Typically in and around May, NOAA will put out the official hurricane outlook for the season. So the number of storms that they predict and the number of major hurricanes versus smaller hurricanes that they predict. So right now, I don't really know what's going to happen this season. And to be honest, no one knows for certain what's going to happen this season. We can look at how the atmosphere is behaving right now and how the ocean is shaping up to get a good idea of how that season is going to shape up. But we can always be surprised. So for example, last year, we predicted an active season, but last year turned out to be the most active season on record. So the best that we can do, and the best that you can do in Alabama, is to always be prepared, no matter if there's 0 hurricanes or 10 hurricanes. Always have a plan in place, know what you're going to do, check on your neighbors, and just always be prepared.
That is very good advice. I think we can all agree as classrooms and as educators that it's really quite amazing that they can forecast a hurricane season in advance, or like what the winter is going to be like. I think that, I'm sure in your role, you marvel this just as much as we do, but it really is quite Miss Ball's class, come on back in. We'll wrap up with our foursome of Ontario classes. Miss Ball's group, come on in.
Hi, Caden had a question about communication while you're flying through a hurricane. Do you lose connection with sort of your base? What kind of modifications do you have to do in that situation?
Gotcha. So on the aircraft itself, we have our internal communication system. So we're all on headsets and we can talk to each other. And a lot of times the meteorologists are talking to the pilots because the meteorologists are looking at the radars and figuring out where the best track through the storm is going to be and telling the pilots, hey, turn 5 degrees to the left, turn 10 degrees to the right, whatever. And communication outside of the aircraft, we have radios that we can talk to air traffic controllers back on the ground. We also have satellite communications, so we can send emails and instant messages to folks back on the ground. And a lot of the scientists will use that to chat with each other, because scientists on the ground will want to see something, and then they tell that to the scientists on board, and then the scientists on board tell the pilots that, and then we try to, get them to a position where they get to see what they want to see. So communication is constant, and it's very important for our job, both during the missions and then after the missions, because if we're not effectively communicating the data that we're collecting to the National Hurricane Center, and they're not effectively communicating those predictions and warnings to you, then that system breaks down, and we're not doing as good of a job as we should. So communication all throughout is absolutely key. And I think it's key in everything outside of hurricane hunting as well.
I think that was a really neat question. I'm not sure we'd had that one before, but yeah, thanks, guys. Mr. Cole's class, come on in, and then we'll go to Hulan and Miss M's class to wrap up in a minute. Mr. Cole, come on up. Hey.
Have you ever encountered a storm while the hurricane was happening?
A storm while the hurricane was happening?
Like a storm in the storm, or?
Like a storm within a storm?
Yeah.
So, yeah, hurricanes themselves are really just, a giant rotating collection of individual little thunderstorms. And so there will be more violent thunder cells within a hurricane, and we'll try to dodge those, because that is really where the most violent parts of the storm overall can be. And sometimes, especially with very powerful storms around the eye, you'll get what are called mesovortices, which are essentially like kind of bigger tornado type structures. We really try to stay out of those, because those can be very violent. So yeah, it's a great question, because yeah, a hurricane is really just a bunch of storms within a storm itself.
That is, I've never heard it described as that, but that somehow makes it more terrifying, like a whole collection of mini occasional tornadoes and tons of thunderstorms.
Yeah.
More power to you. Ms. Hulan's class, come on in, and then we'll wrap up in 1 minute.
Hi, so Travis in my virtual class would like to know, what was the scariest moment in your career?
So the scariest moment in my career, funny enough, was not even in a hurricane. It was actually up on the around the Aleutians in Alaska, and I was helping out with a harbor seal survey up there, and we fly those missions about 500 to 700 feet above the water, but you're flying around these Aleutian islands that are reaching up to as high as 2,000 feet, and so you're flying down these valleys and in between mountains and stuff. And we'd flown over this little set of seals, and the scientists wanted us to turn around, and because they wanted to get better pictures of them. And we're in this valley pretty much between these two islands, and the peaks are reaching up on either side, and we're making a pretty tight turn in between these islands, and being that close to land in an aircraft was much scarier than anything I've encountered in a hurricane so far. So I don't like going on those seal surveys all that much.
For any of our students, I don't know, many of our students may never have been up in a plane. If you have been up in a plane, try and picture that first few seconds when you're coming off the ground and you see cars and buildings around you. I mean, it's a very different experience of being up at 30,000 feet. If any of you have ever landed in one of those airports, you have to dodge between mountains. It's quite the thing. I always like this story, Nick. Miss M's class, we'll wrap up with you guys, and then we'll highlight some cool resources to learn more before we end the broadcast. So unmute that mic, and you are all set to go.
Okay. All right.
How long does a hurricane last?
Come on, say that a little bit louder.
How long does a hurricane last?
How long does a hurricane last? The answer is it depends. It depends on how close it is to land. It depends on what the atmosphere is doing. So it can last anywhere from a day before it dissipates and becomes just a scattered array of thunderstorms again. Some storms can last a long time, and we call those long track hurricanes. So they'll form deep out in the Atlantic. Hurricane Irma was a great example of this, because that storm lasted, I think, like over a week. But it formed out in the Atlantic and then made its way all across the Atlantic, up past the Antilles, up until it made landfall in Florida. And so it really just depends on where it is and what the atmosphere is doing. More powerful storms, though, typically it'll be about a week before they've run their course and they end up hitting land or getting far out into the ocean and losing their structure and really dissipating.
A cool question to wrap us up, Miss M's class. Thank you guys so much for that. And thank you, Nick, for spending a little bit of extra time with us to answer all our questions today. I think we've got like 100 more on YouTube, so more than we can possibly ask in one program. And so what I want to do ever so briefly, just bring up a few quick notes on how you can learn more. Nick highlighted climate.gov and hurricanes.gov. U.S. government websites for science are amazing. Check those out. There's so many great resources and ways to keep learning going. And Nick is on social media at the Astro Nick. Some really, really cool stuff there on his work and beyond. Finally, if you're keen on our Climate Fest, exploringbytheseat.com, all our programs, there's a special events page for all the programs this week. Check that out. And on our YouTube channel, all the programs are going into one big playlist. So Nick, thank you so much for joining us today. And as you know, what we do to end every broadcast, I'm going to bring in all our groups to say a big thank you and goodbye. Miss Foster's class is like chomping at the bit in the background here. Thank you guys.